Good afternoon, everyone. Today I skipped lunch and decided to learn some new stuff, okay? I've been wanting to learn this stuff for so many years and finally it happened today. So I wanted to learn reverse engineering as well as how to actually do it. So here's a code. That's the password. Okay, of course, you don't write a program something like this. When you write codes, you have to store secrets, passwords. Like for example, in Azure, you call it. I think it's called Azure Key Vault, or in AWS we call it Secrets Manager, and I believe it's somewhat similar to GCP. Yeah, the Google Cloud. It's called Google Cloud Secret Manager. But anyways, yeah, I've been so curious about how reverse engineering is done. Okay, so here it's a very basic beginner exercise, and most of them they are called CTF, or capture the flag. And I've been to DEF CON and watched them. It is a very cool event, and where they actually reverse engineer like devices, which is really cool. That's way beyond my head for now. But anyways, so these are the two files. Okay, hex crack me. Yeah, that's the one, right? Hex crack me. And then I had to compile it. And then I used GCC to compile it. Yeah, right there. Okay. And then hex crack me binary, which is ELF 64-bit file, got generated by this command. And yeah, this is the one. Okay. And then I imported it in a disassembler, which is called Ghidra or Ghidra, I don't know. So yeah, this is it. Okay, that's the decompiled or disassembled code. It's in assembly language. Okay, so let's switch to the other terminal here, and I started converting the values, which I think was the password. So in here there were three variables, and I renamed one input because in the decompiled code in this window I saw fgets, okay, which is really nice about Ghidra. It will try to recreate the code, okay, and then that's the input. Earlier it was a local value 58. Since I renamed it here, that changed, right? So now, looking at the disassembled code, I saw this racks register, which I believe is where the array of passwords are actually stored. Okay, let's look at that. Maybe local 20, right? And then somewhere here, yeah, here you go. This one is the first one, another one, and another one. Okay, so I placed them in Python. I didn't have to write a Python code, but I had to just use some functions to convert that hex number. It's actually a combination of 1, 2, 3, 4, 8 bytes, 1 byte. Oops, 1 byte, 2 bytes, and then 8 bytes. And then I have to specify a little endian here because it's read from right to left. Okay, so that thing here gives us do not s. And then the second one, this one, is converted to top lir. Top lir, yeah, top lir, yeah, right here, top lir. And then the last hex value, it's warning. Wow, could be the word warning, yeah. So I combined all all of the 3 hex numbers, which has been converted into ASCII character, and I launch the binary, and then I place do not stop learning, calling the police. Meaning, calling the police, it means my password was incorrect. Yeah, here. If it was correct, this should have been printed, right, or displayed. It's calling this because the password is wrong. So I was wondering, this looks correct, right, based from the value that we saw. And I was wondering, maybe it's a trick, or maybe something I don't understand in the assembly code, right? So I went back to the code. I looked at this and tried to understand how it actually works, how it's actually disassembled. And it's actually not intended by the author of Crack Me or Hex Crack. It's just the way it was decompiled or disassembled. And this line was very interesting. Okay, so the rax value is already the combination of other values because of the move, right? Like assignment. And then look at this. This is the most interesting part. 6. That means it's 8 bytes, right? Now you have to deduct 2 bytes from the value. So that means, or maybe not, maybe the word deduct is wrong, maybe override. So the second one, which is this one, right? Tap lur. It says 8 bytes. 1, 2, 3, 4, which is the space, 5, 6, 7, 8. And -2, go back -2. That means top LE is the word. And then when we combine that with earning, it's going to be do not stop learning. So when I did that, when I typed do not stop learning, correct, yeah. So yeah, guys, this reverse engineering is really cool. Really cool. I'm really enjoying it. And this is just the first part. And I'll be looking for more exercises so that way I can enhance my muscle memory. I think, yeah, so you just have to learn what each assembly language, how do you call this, instructions does. Yeah, maybe having a knowledge on how assembly language works, I think it would help a lot as well. Yeah, and also on C, of course. Yeah, C language. Alrighty, guys, I am really happy about this. This is very exciting, and yeah, I'll post more videos. All right, thank you so much for watching. Later.